Today, I'll present two tasks for the homework. So the first one is the comparator, two 4-bit numbers in single magnitude, comparator, and the other one is universal flip-flop. Okay, let's start with the first one. So the first one is the two 4-bit comparator. So let's say this is comparator. Okay, and we have two 4-bit numbers, A and B. And then we have three outputs. We call them Q0, Q1, and Q2. And if A is greater than 1, Q0, let's do it here, Q0, Q1, and Q2. So if A is greater than B, if A is greater than B, then we have 1, 0, 0. So the first output indicates that the A is greater than B. If B is greater than A, then we have 0, 1, and 0. So the second output indicates that the B is greater than A. And if they are equal to each other, then we can see the third output being on. So it has 1 in the output. Okay, so let's see this in the code of ISP level in VHDL. So this is my code. Okay, let's go back to Paint. Okay, so these are two 4-bit numbers in sign magnitude. So we know that the first number indicates the sign. So if it's 1, then it's negative. If it's 0, then it's positive. So in the first line of the code here, I compare the most significant digits of those two numbers. And if A is greater than B, so if the most significant digit of the A is greater than the most significant digit of the B, it means that the digit of the A is 1, which means that it's negative. So if this number is negative and B is positive, then we know that B is greater than A, so Q1 is 1. In the other case, if the B3, so the most significant digit of the B is greater than the most significant digit of the A, that means that the B is negative and A is positive, so A is greater than B. Then we have three remaining digits, A2, A1, and A0. So those digits can be compared. So let's say if this is 1, 0, 1, 0, and this is 0. Okay, let's get back. If it's 1, 0, 0, 1. So if the first two are equal to each other, we have to compare the next two. And then if the next two are the same, we compare the third numbers. And now we can see that the number of A is greater than B, hence A is greater. So we can see it in this line of code. So we have the loop. It goes from 2 to 0, and if the most significant digits of the numbers are the same, then we compare the next digit. And if the next digit of A is greater than B, then we know that A is greater than B. And then we can exit the loop. And then the other case is if the next digit of B is greater than A, then we know that the B is greater than A. And we can again exit the loop. If they are the same, we go again and we start again the loop and we look for the next digit. So this is if A of 2 and B of 2 are the same, we look for A of 1 and B of 1. If they are the same again, we exit the loop and we can say that A and B are the same. So the third output is on. Let's take a look at the test bench. It's here. Okay. So for the test bench, I did like 1, 2, 3, 4, 5 comparison of those two numbers. So in the first case, we check the sign of the number, so we can see that the A is negative and B is positive. In the second case, we can see that the first numbers, the most significant numbers, are the same, so we compare next numbers. In the third case, we can see that the first two numbers are the same, so we compare the third number. This case, we have the same three numbers, so we compare the last numbers, and the last case we have two the same numbers. If we simulate this, okay, so yes. Okay. Okay. So we have it simulated. Let's zoom in. Okay, and let's see. Okay, so the first case. Okay, so we can see that the A is negative because the most significant digit is 1, and B is 0, so it's positive. Then we know that A is greater than B. Sorry, B is greater than A. Yes. Okay, in the next case, the A has value 6 and the B has value 2, so we know that the A is greater than B. So the Q0 is 1. Next case, we compare those numbers again, and we can see that the first two numbers are the same, it's 0 and 1, and then we can see that the third number is greater in the A, so the A is greater than B. You can see it here. And then next case is, again, we compare the numbers, and we can see that the last digits are different. We can see that A is greater than B, so Q0 is 1. And in the last case, both numbers are the same, so Q2 is 1. And that's it for the comparator. Now, let's take a look at the second task, which was the universal flip-flop. So let me just create a new file. Okay, so I created a universal flip-flop. So this is my uni flip-flop. It has four inputs. So this is input 1 and input 2, or actually I call it 0 and 1. And this is the selector, so selector 0 and selector 1. And we have one output Q. So we can, using selectors, we can select which type of flip-flop we want to use. So let's say if it's 0 and 0, then we use D flip-flop. If it's 0 and 1, we use T flip-flop. If it's 1 and 0, it's RS. And then if it's 1, 1, it's JK. And in the different cases, we have either one or both of the inputs. So in the case of D, it's only input 1. If in the case of T, it's T. Then it's R and J. And this is, if you need two inputs, you use this one as S and this one as K. And that's it. Okay, so let's take a look at the code. Let's open the flip-flop. Okay, and here you can see that with the running edge of the clock, each time we check the position of the A and B, which are the selectors. So if it's A is 0 and B is 0, then we have the D flip-flop, as I said here. Yeah. Let's do it like this. Okay. So if it's 0 and 0, it's D flip-flop. So if it's 0 and 0, it's the D flip-flop, so the value of the input goes to the output. If it's 0 and 1, it's the T flip-flop. So the T flip-flop, it works like this. Q of T plus 1. So if it's 0, then it's Q of T, and if it's 1, it's the negation of the last signal. So if it's 1, we can negate the last signal. Okay. Then in the case of 1 and 0, it's RS flip-flop. So if if set input is 1, then we have 1 on the output. If reset input is 1, then we have 0 on the output. If both set and reset are 1, then we get an error because this is not, you cannot do it. It's going to give you an error. And then the last flip-flop is going to be a JK flip-flop with 2 1s. It works the same as RS flip-flop, so if it's on the K is 1, then it's 0. If there's 1 on the J, it's 1 in the output. And then if in this case, if both inputs J and K are 1, then you have the inverted. You have to invert the last signal, so it's Q equals not Q. Okay, let's get to the test bench. So this is my test bench. I'm going to just check different flip-flops. So in the first case, this is the apparently this is JK flip-flop. Okay, so and we have input 0 on 1, so it's we are setting 1 for the output. Okay, then we wait for 15 nanoseconds, and then we set, I guess this was T flip-flop. Yes, that was T flip-flop. It's T flip-flop. And what we are doing, we again using input 0 is 1, so we have to toggle the output. So it's going to invert the last signal. And then the last case, I guess this is RS, and then if you have 1 on the input 1, I think this is the set options that's going to give me 1. Okay, don't save it, and then let's run the simulation. Okay, it's here. Yes. Okay. So as you can see, let's move clock tool here, and okay. So in the first case, we have A and B on 1. So this is the JK flip-flop. The input 0 is 1, so it's going to set 1 for the output, and yes, we can see that the output is 1. Then here we change to T flip-flop. The input 0 is 1, so it's T equals 1. So in this case, it's going to switch the state. So you can see here, it switched to 1 from 1 to 0, and then again from 0 to 1. And then once more from 1 to 0. Okay, next we use 1 and 0, which is RS flip-flop. If both inputs are 1, if both inputs are 1, then we can see there's an error because you cannot use the state. And that will be it for this homework. Thank you for your attention, and goodbye.